Okay, it's time to talk about everybody's favorite in algebra, polynomials. And a polynomial is simply, could just be just a monomial or the sum of monomials. And remember, a monomial is just a number or a variable or the product of both. So in this case here, my polynomial, I have 4 monomials inside of here, right? Here's one of them, negative 3y squared. I also have a negative 2y, a positive 4xy, and a negative 1. And we call all of our monomials inside our polynomial terms. These would be the terms of the polynomial. So whenever I use that word terms, that's what I'm talking about. So in this case, I have 4 terms. And we can actually classify our polynomial by how many terms it has. For example, we've already dealt with the first one. If there's just one term, just a monomial, that's what it's called, a monomial. Hence the prefix mono, which means one. There's just one term. Whereas I get to a binomial, there is 2 terms. And if you look at the prefix here, bi, bi, that means 2, like a bicycle, right? 2 wheels on a bicycle. So there are 2 terms in a binomial. Well, think about 3 terms. What's a prefix for 3? How about tri, right? Tri, like a tricycle or a triceratops. So that has 3 terms, right? 1, 2, 3 terms. So it's a trinomial. Anything with 4 or more terms, we just simply call it a polynomial. There's no special word for that. So 4 or more, we'll just call it a polynomial. Right? It doesn't matter what the exponents or anything like that are. It's just called a polynomial. We can also talk about the degree of our monomials and our polynomials. So let's just look at the degree of a monomial. Well, if you think about the word degree, we're talking about our exponents. Exponents of the variables. And if you look at the definition here, it's sum of the exponents of all its variables. So really all I'm doing is I'm just counting up my exponents on the variable. So in this case, I have a squared and b to the third. So I have a 2 and a 3. So all I do is I add their exponents. So the degree of that monomial is the 5th degree. So I guess I could write that. I could write it as the 5th degree. Or you could just say it's to 5, right? To the degree of 5. Looking at the next one, I have y to the 5th, and I got an x and a z. Just remember, if it's just a variable, there's an imaginary 1 for the exponent. So it looks like I got a 1 plus a 5 plus a 1 for the 7th degree. The 7th degree. Okay, so that's how you find the degree of a monomial. And there's some words for specific degrees. Like the first degree is a linear. All right, if I were to graph a first degree monomial, I would get a line. So the second degree is a quadratic. We'll spend a lot of time talking about quadratics. And then there's the 3rd, 4th, and 5th degrees. If it's to the 0 degree, it would be to the 0 degree. Let's look at that one. Goes to the 0 degree. That means my variables all have a 0 degree. Let me just make one up here. Let's say I had 3a to the 0, b to the 0. Well, remember, anything to the 0 degree is just a 1. So really I have 3 times 1, which gives me 3. So the 0 degree is called a constant, which we've already talked about, right? Because the number 3 doesn't change. So anything to the 0 degree is a constant. We won't spend a lot of time with that terminology. Just know how to find the degree of a monomial. Now, if I'm trying to find the degree of the entire polynomial, one might think, well, I just add up the degrees of all the monomials. But that's not how it works. We just want to find the greatest degree of any term. The greatest degree of any term. So basically, whichever term of my polynomial has the most exponents on the variables will be the degree of the polynomial. So if I look at my first term here, 2d to the 3rd. I got d to the 3rd, so that would be to the 3rd degree. Looking at my second term, I have a c to the 5th and a d to the 1st. So 5 plus 1 gives me 6. That'd be to the 7th degree. And my constant, right, there's no exponents, that'd be the 0 degree. And all I look for is the greatest degree, just like we just talked about, the greatest degree of any term. So it looks like 6 would be my greatest degree. So this would be a sixth degree polynomial. Okay, so you just find the greatest degree of any of the terms. Looking at a couple examples, we'll just go through this quick. You just count up the degree. This would be to the 0 degree, 5b is to the first degree, bc would be to the second degree, and bc squared would be to the third degree. So there you go. This would be to the third degree. Not much to that, finding the degree of the polynomial. Same thing over here. This would be to the second, third, fourth, 0. You just pick the greatest one. So this polynomial, the entire thing would be to the fourth degree. We also like to write our polynomials in standard form. So what we're going to do is just write our terms in order from greatest degree to least degree. So once again, we're just finding the degree of each term. So in this case, it would be to the third degree, second degree, first degree, 0 degree. So this is already in standard form, right? From greatest to least. So I got 3, 2, 1, 0 of my degrees, greatest to least. So that is in standard form. So we'll try a couple here. So we want to write these in standard form. And then we're also going to identify the leading coefficient. And I'm going to talk about that once we go through this first one. So if we look at this 8, that's to the 0 degree. Negative 2x squared is the second degree. 4x to the fourth is the fourth degree. And negative 3x is to the first degree. Now, don't forget to carry the sign that's in front of each term. So for example, the fourth degree is my greatest degree here. So I want to bring this positive 4x to the fourth out front because that's the greatest degree. Okay, done with that one. Then I'll bring my negative 2x squared, right, because that's to the second degree. Done with that one. And bring my negative 3x, because that's the first degree. And finally a positive 8. And there we go. That would be standard form. And my leading coefficient, it's just, remember the coefficient is the number in front of your variable. Well, the one out front is my 4x to the fourth. So that would be the coefficient, the leading coefficient. I'll just go with F there. Same thing with the next one. Find all the degrees of each terms. So first degree, third degree, second degree, sixth degree, 0 degree, and then we just go greatest to least. Remember to bring that sign that's in front. So I'm going to bring my negative 7y to the sixth, positive 5y to the third, negative 2y to the second, plus y plus 10. And then we'll circle our leading coefficient of a negative 7 there. Okay? So that's what we always want to write those polynomials in standard form. Lastly, let's look at one more example here. It says write a polynomial for the area of the shaded region shown. Well, first of all, we're going to think, how are we going to find that shaded region? Well, I got a couple rectangles. I got a big rectangle, and I got my little rectangle on the inside. And if I think about it, if I find the big area, the area of the bigger rectangle, and I subtract the area of the small rectangle, that should give me my shaded region. Should equal that shaded area. And how do we find the area of a rectangle? Well, length times width, correct? So that's what we're going to do. So my big rectangle, looks like I got 4x times 2x minus the small area, 2x times x equals the shaded area. Well, let's simplify here. 4x times 2x gives me an 8x squared minus 2x times x to an x squared. And we have like terms here. They're both x squared, so I can combine those to give us a 6x squared for the area. And we just say units squared because it does not specify any units. All right, so you just got to take the big area minus the small area and just go through some algebra there. Okay, that's all we got for polynomials. Thank you for watching.